Hello, students. We are jumping into the MCs, the Math Connections for section 7.3. Let's see here. We had 3 through 6, 9 through 11, and 13 through 15. So let's take a look at a few of these, 3 through 6. So yeah, this is such a great question. A lot of students say, I'd rather do everything in decimals. Once you see that decimals are repeating, it is an absolute nightmare to try to add those together and be accurate all the time, especially if you get different periods, if you have different length of the repetend. So again, tough call. Sometimes decimals are quicker than the fractions because you looks like you may not need a common denominator, or it doesn't require you to do something very quick with those, especially if they're terminating. If they're repeating, then yeah, maybe not. It takes a little longer. So describe situations for that one. Find decimal expansions of 1 over 11, 111, 1111, and guess the next one. So kind of building a pattern. They want you to kind of figure this out. You'll notice in question 5, this is similar to what we did in class. All we had is that's where we built the bracelets today. Suppose you memorize the decimal form for 1/7. How could you quickly find the answers for the other decimals as described above? Okay, so that is 3 through 5. Oh, I said 3 through 6. So multiply each of the following, give your answer as a decimal in simplest form. So take a moment when you're doing that and say, okay, I've got, like this, 2 times 0.3. You might be able to kind of see what it is over time. You can always rewrite this as 2 times 3/9. You can always do that. And 3/9 is really 1/3, or you can multiply first and get 6/9, and the goal would be, this would be 6/9, which, that's a 9, horrible 9, is 2/3. Okay. So there is 3 through 6. Let's take a look at the other ones that I have selected. 3 through 6, 9 through 11. All right, using the digits 0 through 9 at most one time each, fill in each of the boxes with a single digit so the fraction equals the repeating decimal. Okay. So yeah, I'm just making sure I read that right. So you have a box in front, because over here, if you had just a single digit being repeated, like a 0.5 repeating, that'd be 5 out of 9. So they're giving you that extra little piece over here, another digit, and saying, okay, let's actually make that work. Okay. All right, let's see. You're connecting math to the classroom. Student argues repeating decimals are of little value because no calculator will handle computations with repeating decimals. Okay, well, I'm looking forward to your responses there. It says they're of little value. Okay. I think students always say that about something that they may not fully understand. Oh, and I go through number 11 too. Student asks if a sum of 2 repeating decimals is always a repeating decimal. How do you respond? Okay, when a student asks a question like that, maybe try some. Take some smaller ones. See what makes 2 decimals repeat. But also think back to what we've showed in class, right? Does it mean that something has to be repeating? So keep that in mind as you do number 11. So I think I then did 13 through 15 or 13 through 15. Okay, so a couple extras here. Dean says terminating decimals are those with a repetend 0, and non-terminating decimals are those with non-zero repetends. Is this correct? Now, again, the book may not even define it. Maybe Dean's trying to come up with something on his own, but does it make sense? Would that be the case? Okay. And Edric used a calculator to compute 1/7 as this number. Awesome. Multiplies that decimal by 2 to get the decimal approximation for this one. What do you think? Does it work? Is this a valid approach by Edric? And lastly, um, yeah, student says 0.4 is 4/9 and 0.44 repeating is 44 over 99. So therefore, these can't be the same because, as you noticed, if they were the same, they would have the same fraction. How would you respond to a student who has done something like that? All right. So that takes us up to number 15, and that should take care of this for tonight. And when, thank you so much. If you have questions, please let me know. Otherwise, I will see you soon. All right. Off you go.